Welcome to this course about simple CPU communication feature, where we will see in detail the description of its use with Mitsubishi Electric controllers and third-party devices. The simple CPU communication function is available on the Melsec IQR and Melsec IQF platforms. The feature allows the configuration of data exchange between devices in a simple and intuitive way, via parameterization and without programming code. This function was added to the hardware modules and to the software development environment after their release, with the purpose of managing data exchange with the previous series of the Melsec controllers. Over time, optimization have been added to the function, including the possibility to communicate with third-party devices. Please check the firmware versions of the modules used and the software version of the GXWorks 3 to perform a correct configuration. Let's take a look at the relevant specifications of the function on the Melsec IQR platform. The functionality is present on the built-in Ethernet port of the entry-level CPU, on the standard CPU, and on the standard CPU with the coupled Ethernet module. Recently, the function has also been inserted on the built-in Ethernet port of the safety CPU and process CPU, even on redundant systems. It is not present for the SIL2 process CPU. On the built-in port of the CPU, we can manage data exchange only with Melsec controllers or with devices compatible with the SLMP protocol, where we have a maximum of 16 connections to external devices. Differently, on the RJ71EN71 Ethernet module ports and on the network part ports for the standard CPU with coupled Ethernet module, we have the possibility to manage data exchange also with third-party devices. In this case, on each port, we have a maximum of 64 connections to external devices. Be careful, because only the RJ71EN71 Ethernet module allows you to set both ports in Ethernet mode. Regarding the specification on the Melsec IQF platform, we can see that the functionality is present on all CPU modules and on both Ethernet modules. The differences are mainly on the maximum number of possible connections to external devices. As you can see from the table below, only on the CPU modules we have the possibility to organize the data exchange with all the devices available in the specification. Instead, on the Ethernet module, we can manage the data exchange only with other IQF systems and also with the Modbus TCP compatible devices. How to manage the function on the Melsec IQF platform to exchange data with Melsec IQR controller. In the example, we have kept the default IP addresses of the built-in Ethernet ports of the CPU. In fact, on the Melsec IQR platform, no specific settings are necessary. Let's start looking in detail at the function configuration page. On the upper part, as the first field, we have the latency time, that is the delay time for the function to start. If we are on the CPU port, the delay count will start after the CPU run status. Instead, if we are on the Ethernet module, the delay count will start after the module ready status. The second field at the top is dedicated to the IP address filter of the setting visible in the list below. For the FX5 CPU modules and for the FX5 Ethernet module, the available settings are 32. Just for the CPU module FX5S and FX5UJ, the available settings are 16. On the IQR series, the settings available on the CPU port are 64, compared to the 512 available on the Ethernet module ports. The setting develops horizontally, and as a first step, we insert which action we want to perform, read or write to the destination. As a second step, we shows how the setting number is executed, on fixed interval with the time in milliseconds indicated in the field next to it, or on request via a bit of the buffer memory. In the central part, we will insert the device type with which we want to communicate and its IP address, in this case Melsec IQR built-in Ethernet. Regarding the management of assigned port, for the port number, for Melsec device, the ports are fixed and automatically assigned, except for Melsec FX3. For all others, respect the relative range of the selected device. Please check the manual. For the host station port number, when using the same communication destination in multiple setting number, it is suggested to change the port number. If using with Modbus TCP or Siemens, it is possible to use the same port in multiple settings. Please respect the following range for IQF and IQR to the port. The option value is only valid for configuration with Modbus TCP compatible device. Finally, in the field Target PLC number, it will be possible to assign the CPU number of a Melsec multi-CPU system and also some third-party multi-CPU system. Continuing horizontally on the list of settings, we will find the data exchange area between source and destination, divided into bit device and word device. Here we can enter a range of values based on the device used, which are specified in the manual. Relative to our example, in the tables we can see the device supported for the simple CPU communication function on Melsec IQF as host station, and those supported by Melsec IQR as destination station. In the example, we have organized the two settings in read and write to exchange the status of 16-bit. The Y1000 outputs are transferred to the X1000 inputs for both stations. Instead, for the exchange of word values, in the first setting, the Melsec IQF reads 16 register from the Melsec IQR, from the D100 device. And vice versa, in the second setting, the Melsec IQF writes 16 registers on the Melsec IQR from the D200 device. In the final part of the settings list, there is the possibility to manage the timeout times, the number of attempts to wait for the response from the destination station before generating the error code, and finally the monitoring time to update the error code. Let's look at this dynamic in more details. As we can see in the image, from left to right, the Melsec IQF executes the function at fixed intervals with a cadence of 100 milliseconds towards the Melsec IQR. The first communication is successful, and the second creates a problem. At this point, the timeout time count will begin, in the example equal to 1000 milliseconds. Begin with a series of 3 communication retry counts, as set. Subsequently, if communication fails, the error code is provided in the buffer memory. From this moment, the function enters a monitoring state where the error code is updated after the set time has elapsed. In this monitoring phase, communication is automatically reestablished when the problem is resolved. In the on-request mode of setting, the monitoring phase is not performed and the function ends the execution after the end of the communication retry count. The error code is then provided and the setting goes into a state of waiting for a new trigger to execute it. To check and diagnose the function status, we have the module label section dedicated to the simple CPU communication function. This part of the module label is organized with arrays of 32 values, as the number of settings available on the FX5U CPU module. The start request bit is used and valid only to send the trigger for the on-request settings. The stop request and the restart request bits are only used for fixed interval settings. In the status flag bit, we have the feedback of the execution for the settings. The ready bit notifies if the setting has been prepared by the system and is ready to be used. The status simple PLC value provides the code with which we can recognize the execution status of the setting, as you can see in the description table on the right. Next, we have the error code value relating to the error code that is provided following a communication problem in the setting. Then, we have the current execution interval value, which gives the execution time of the single setting. Finally, we have the value abnormal response code, with which we can diagnose the response that the destination station sends back if the communication provides an error code CFB4, which means an abnormal response has been received from the device. For example, in Modbus TCP, the exception code is provided. We can find the description in the manuals listed below for the MELSEC IQF and MELSEC IQR. For the diagnostic of the function, it is also possible to use the dedicated page directly from GXWorks 3. In this diagnostic page, we have visibility of the status for each individual setting, where, in the example, the first 6 settings are normally operational, and setting number 7 presents a problem and the relative error code is indicated. For the detail of the error codes that are provided, consult the manual. Let's now see the simulation video of the example we just discussed. On the left side of the screen, we have the FX5 project and on the right side the R series project. In both projects, group of labels were created relating to the data exchange configured in the example, using the addresses to device X, Y, and D. An identical logic was created on boot stations that animates the first 3-bit outputs with the always-on state, with the clock at 1 second, and with the clock at 2 seconds. Instead, for the first 2 output registers, the cycle time value is exchanged. Finally, in the video, we simulated the bit and word data exchange between the 2 stations. Let's continue now with the example of how to manage the function on the Melsec IQF platform for data exchange with a Modbus TCP compatible device. In the example, we used a Mitsubishi Electric inverter model FRE800. Regarding the FRE800 inverter, the models to be used are with the final acronym APA or APB because they are compatible with the Modbus TCP communication protocol. The fundamental parameters for configuring the inverter are the following. In one of the parameters from 1427 to 1430, we will have to insert the value 502 to enable it to be controlled in Modbus TCP. Parameter 1432 is dedicated to the management of the communication timeout by the inverter. In the example, by inserting the value 9999, the timeout control is disabled. Then is necessary to align the IP address of the inverter in the parameter from 1434 to 1437. In our case, we have only updated the value of the third octet compared to the default value, from 50 to 3. Finally, it is mandatory to insert the range of IP addresses that can communicate and control the device from parameter 1449 to 1454. Let's now move on to configuring the setting for simple CPU communication function on the Melsec IQF. In the fourth settings, we entered the device type Modbus TCP compatible device and its IP address. Regarding the ports to configure, the port number is automatically entered as 502, but is possible to change it. On the host station port, as mentioned above, when we communicate with the same Modbus TCP device, in multiple settings, it is possible to keep the same port. In the example, we have entered port 1024 for all 4 settings. As we said before, the field option in hexadecimal is only available for communication with Modbus TCP compatible devices and specify the station identification ID. We can divide its use into 2 cases. The first case is when communicate with a Modbus TCP device, and the value that can be entered will be 0 or FF. For example, the FRE800 accepts both values, while the FRA800 and FRF800 models only accept the FF value. The second case is when we communicate with a Modbus TCP gateway device, and it has Modbus RTU ASCII device connected under it. In this case, it is necessary to enter in the option field the number of the station to read or write data to the Modbus RTU device. We can pass now to the description of the data exchange that we have prepared with the FRE800 inverter. First of all, the manual indicates the values to be respected to enter the coil input and register addressing. Remember to evaluate whether to subtract -1 from the addressing. It may depend on the settings for the Modbus TCP destination station. In the following table, we can see the list of the holding register for the FRE800, and with the green tick we see the ones used in the example. Setting number 3 at fixed time intervals reads the holding register that provide the inverter status, the operating mode, and the frequency set on the RAM memory, and transfers them to the PLC memory from the D309 device onwards. Setting number 4 executed at fixed time intervals the writing of input commands and the operating mode to the inverter from the PLC device memory D409 and D410. Finally, for example purposes, setting number 5 and 6 are executed on request and managed with a logic on PLC that generates the trigger when you want to send the reset command or change the frequency set on the RAM. In the example project, labels have been organized with addresses aligned to the settings, so as to have a control dashboard on the GXWorks tree. Let's see the simulation of the example with the FRE800 controlled in Modbus TCP. On the left side of the screen, we have the FX5 project, and on the right side, we can see the hardware dynamics in real time. From the watch table of the GXWorks tree, we go to check the status of the inverter and what frequency we have set, which, as you can see, is equal to 60 Hz. Subsequently, we enable the run command and the inverter begins its acceleration ramp up to the set frequency. We go back to check the status of the inverter, where the respective bits of the register are updated. At this point, we go to enable in sequence the low speed commands, 10 Hz, then medium speed at 30 Hz, and finally high speed at 50 Hz. And we see that the inverter changes its frequency. By removing the commands, the inverter returns to the previously set frequency of 60 Hz. As a final test, we simulate the disconnection of the inverter Ethernet cable, where the error is reported with the consequent stop of the motor. The action that the inverter must do when it loses the communication can be managed by parameter. After reconnecting the Ethernet cable, by sending the reset command, the inverter restarts with its acceleration ramp up to the previously set frequency of 60 Hz. Regarding the use of the simple CPU communication function for data exchange with a third-party device from the list, please contact us. Thanks for your attention.